Show by the principle of mathematical induction that for all n belonging to the set of natural number n, the expression 7 raised to the power 2n plus 2 raised to the power of 3n minus 3 times 3 raised to the power of n minus 1 is divisible by 25. Okay, let us begin. So here in this problem, we are not being asked to show that this expression is divisible by 25. Rather, we have to show that this is a statement, a mathematical statement that is true for all natural numbers, meaning any values of n that we choose, and n has to be a natural number, that whatever expression that we get, whatever value that we get, that value must be always divisible by 25. Okay, let us begin. So first what we'll do, we are going to consider a statement P of n. So let P of n be the statement which is given by P of n such that 7 raised to the power of 2n added to 2 raised to the power of 3n minus 3 multiplied to 3 raised to the power of n minus 1. So this expression is divisible by 25. So we have converted it into a mathematical statement. So we're going to name this as statement number 1. Now, in order to show that this statement is the true statement, we will check for n equals to 1. That means for the first natural number 1, we'll check whether if the statement is actually a true statement or not. So we'll calculate P of 1. So P of 1 is simply replace the value of n with 1. So we have 7 raised to the power of 2 times 1. So that's 2. Added to 2 raised to the power of 3 times 1 minus 3. So that's simply 0. Multiplied to 3 raised to the power of 1 minus 1. So that's 0 as well. That's going to give us 49 added to, we have 2 raised to the power of 0 times 3 raised to the power of 0. That's simply 1, which gives us 50. And we know 50 is indeed, it is indeed divisible by 25. So that means our statement, here we can say that the statement P of n, this particular statement is true. This is true for the first natural number. That means if we choose n to be equals to 1, then our statement comes out to be true. But we also need to show that it works for other natural numbers as well. So here we are going to begin with a supposition. We will suppose that let P of m be true. We're saying that P of m is also true. So if P of m is true, then we have to rewrite our statement. So we'll take the help of the statement number 1 Pn and use it to construct the statement P of m. So P of m will be 7 raised to the power of 2 times m added to 2 raised to the power of 3 times m minus 3 multiplied to 3 raised to the power of m minus 1. And we're saying that this statement, this expression is divisible by, it is divisible by 25. Okay, so let's call it statement number 2. So here we are starting with the assumption that P of m is true. And using this statement, we will need to show that if P of m is true, then P of m plus 1, where m plus 1 corresponds to the next consecutive natural number to that of m. So that means our statement becomes 7 raised to the power of 2 times m plus 1 plus 2 raised to the power of 3 times m plus 1 minus 3 multiplied to 3 raised to the power of m plus 1 minus 1. So we have to show that this expression is divisible by, it's divisible by 25. So let's call it number 3. This is statement number 3, which we need to verify. Now, in order to verify number 3, we're going to take the help of statement number 2. Now, from 2, as we have already mentioned that P of m is a true statement. So what we can do, we can take the statement 7 raised to the power of 2m added to 2 raised to the power of 3m minus 3 multiplied to 3 raised to the power of m minus 1. Since it's given that this expression is divisible by 25, now what we'll do, we will express it as a multiple of 25. So we'll take 25 times lambda, where lambda is a natural number. Lambda belongs to the set of natural number n. Okay, so let's call it number 4. Now we will use this fact to verify statement number 3. So now in statement number 3, what we'll do, we'll take 7 raised to the power of 2 multiplied to m plus 1 added to 2 raised to the power of 3 times m plus 1 minus 3 multiplied to 3 raised to the power of m plus 1 minus 1. So let's try to simplify this expression. So we have 7 raised to the power of 2m plus 2 added to 2 raised to the power of, so 3 times m, we have plus 3 minus 3. So let's keep it as 2 raised to the power of 3m. Then we have 3 raised to the power of m. Fine. Now using the laws of exponent, what we can do, we can rewrite the first term 7 raised to the power of 2m plus 2 as 7 squared multiplied to 7 raised to the power of 2m, or in other words, we can express it as 49 multiplied to 7 raised to the power of 2m. Plus, we'll keep the second term as it is, 2 raised to the power of 3m multiplied to 3 raised to the power of m. Now, the reason why we use the law of exponents here, because now we have 7 raised to the power of 2m. If we check out number 4, so in equation number 4, what we can do, we can keep 7 raised to the power of 2m on the left hand side and transpose the second term, 2 raised to the power of 3m minus 3 times 3 raised to the power of m minus 1 to the right hand side. So that means we now have 49 multiplied to, now in place of 7 raised to the power of 2m, we have 25 lambda minus 2 raised to the power of 3 times m minus 3 multiplied to 3 raised to the power of m minus 1 added to 2 raised to the power of 3m times 3 raised to the power of m. Okay, let's distribute 49 with each of the two terms within the parentheses to get 49 times 25 lambda minus 49 multiplied to, now we have 2 raised to the power of 3m minus 3. We can express it as 2 raised to the power of 3m divided by 8 multiplied to, we have 3 raised to the power of m minus 1, but we can express it as 3 raised to the power of m divided by 3 added to 2 raised to the power of 3m times 3 raised to the power of m. Now, in the second and the third term, we can take 2 raised to the power of 3m times 3 raised to the power of m as the common factor. Okay, so we will be left with, now we have 49 multiplied to 25 lambda. So let's write down the left hand side as well. So we will take 2 raised to the power, let's take positive 2 raised to the power of 3m multiplied to 3 raised to the power of m as the common factor. Now that means we're considering the third term first, so that's going to be 1. And from the second term, we are now left with 49 over 24. Fine. Now, we have 49 multiplied to 25 times lambda minus 2 raised to the power of 3m times 3 raised to the power of m, 25 over 24. Now, in each of the two terms, so we have one term and the second term. So from both the two terms, we see that we have 25 as the factor, so we can pull it out. So we have 25 multiplied to 49 lambda minus 2 raised to the power of 3m times 3 raised to the power of m whole divided by 24. Fine. Now, we have already considered lambda to be a natural number. Similarly, m is also a natural number. So whatever values of lambda and m we take, this expression within the parentheses is always going to be some natural number. So instead of rewriting it again, we replace it with beta, where we are saying that the expression 49 lambda minus, we have 2 raised to the power of 3m multiplied to 3 raised to the power of m divided by 24. We're saying that this particular expression can be also expressed as beta, where beta belongs to the set of natural number n. Okay, so what we have done, we started out this particular expression, we were able to show that it is a multiple of 25. If it is a multiple of 25, this simply tells us that the statement p of m plus 1, the p of m plus 1 is a true statement. So this is telling us that it's a true statement, because we can simply say that 7 raised to the power of 2 times m plus 1 plus the second term, this expression is divisible by 25. Now that we have shown that p of m plus 1 is also true, provided p of m is true, We can generalize everything and finally say that hence the statement, the original statement P of n, this is a true statement by the principle of mathematical induction and is going to be true for all values of n belonging to the set of natural number n. That means any natural number that we take, the statement is always going to be a true statement. You can actually check if you choose the natural number n to be such that, so let's go to our original expression. So here we have the original expression given by the statement Pn. So any n value that you take a small value of n that will help you easily calculate the value of the expression. So take n equals to 3 and you will see that whatever result that you get, whatever number that you get, that is going to be divisible by 25, and it's going to be true for any natural number that you pick up.